Good evening. Welcome to my weekly live stream on Node-RED development. I'm Nick O'Leary, project lead for the Node-RED project. This is my weekly hour or so spent working on Node-RED itself, fixing up issues, working on new features, whatever might need doing. So if this is your first time joining, welcome. Do say hi in the chat. If you're watching on the YouTube video, please do leave a comment, like and subscribe as you will. So yeah, it's really my opportunity just to spend a bit of time working on Node-RED, sharing how I do things, hopefully unveiling new and interesting things for you. Yeah, so that's the plan. Right. Now it looks like my mic is peaking a lot. So if you are watching the live stream, let me know how the audio is. Do I need to turn things down a bit? Yeah, so if you're watching live, do join the chat, say hi. Hi, Softy2K, good to see you again. Yeah, audio's okay. Good. Okay, well, I have no feedback other than what you guys say. So, cool. So what are we doing? Yeah, and hi to you. Hi to everyone in the chat. So what are we doing this week? So an interesting... So I had a plan for tonight, but that's kind of been swept aside because a guy in the community, Make Hummel, and Slack, in fact, let's bring that up, posted an interesting message this morning around a weird issue they're seeing with that they've got a flow with something like 1,000 nodes, which that's on the big side, but we want nothing unordinary about that. So they find the editor tends to freeze when when they are loading up the flows. And they've seen that it's related to the status messages coming from nodes to the editor. So I'm going to sort of talk through about how all of this works a bit. But what's interesting and what sort of caught my attention is each time they're doing a deploy, it's getting worse. And in fact, you can see some numbers here in his message saying, so from a clean restart, he gets 502 status messages just when they load the editor, and after they do a deploy, they get about 2,500. They do another deploy, they get 4,500, then 6,500, 8,500. Basically, every time they're doing a deploy, they're seeing this almost linear growth in how many status messages the runtime is sending the editor, and yeah, well, that is not good. In theory, the status messages, there should be at most one per node, because sending status updates, it's only nodes that send status. So it's curious that each time they deploy, that they see the steady growth, even if they don't add nodes. So that caught my attention, and that's a definite bug that needs fixing. And I did a bit of digging with them just to understand what was going on, and they're using subflows. And that kind of pointed me straight at what the problem is. So we're going to spend a bit of time just fixing that. But I suspect there's going to be some other areas for improvement, because this is a workload the editor has to do whenever you open up the editor. It has to get the current status of nodes. And there is some work. I will admit I've done a bit of research before this stream tonight, and I have identified some efficiencies we can add in, so I'm going to be sort of working through those a bit this evening. So that's the goal. That's the goal. That's what we're going to work on. So perhaps the best thing to do is just to look a little bit about what's the actual mechanism. How does a node calling node.status end up something happening in the browser? So let's just pull up, just again, make sure make sure we're on the same page. So what have I got changed in here? So I have been poking around a little in some of the nodes. In fact, I'm gonna revert some of this work because I'm going to sort of step back through it with you here and now. So we're going to run node red. Oops, not with devb, just run grunt dev. What's your question? What's the command? Oh, the ti command. Sorry. Yeah, so I'll quickly show you that. There is a command line tool called tig, which is git backwards, but if you run it in a git repository, it gives you a nice browsable UI for the git status, and by default it shows you the list of commits, and if you press S it goes to the status view, so it shows you changes and things to commit, and you can stage them and commit them all from the UI interactively. And ti is just an alias I have that takes me straight to the status view, and it's a bit quicker to type. So yeah, good question. That's what that is. But tig, yeah, if you're doing a lot with git on the command line, it just gives you that interactive way of working with git, which I prefer. Right, so we've got Node-RED running. So just for the avoidance of doubt, we're looking at these status messages that show up under nodes. So here I've got a debug node configured to log its output to node status. So you get a little status message. HTTP request nodes will log status when they're performing a request. Function nodes, obviously you can write node.status in that code and it will log status. So what happens when a node, so here we are, this is node, let me make it big. All these things I forget to do ahead of time. Right, I'll turn off minmap because, no, I won't. Right, here we are, this is node, this is sort of the superclass for all the nodes in a flow, and this is where node.status is actually defined. So you can call it either with an object, which is a status object, with fill, shape and text, or you can, and this is a relatively recent addition, just call node.status with a bit of text and or a number or a boolean, and we'll automatically sort of wrap that up as a proper status object. You call that, and what the node does is it calls its parent flow handle status. So let's go have a look at, so here we are in, let me just show it in the tree. Oops, no, don't do that. Don't want breakpoints. Don't do breakpoints in here. Where are we? So we're in the runtime module, lib flows, flow.js, flow with a capital F because it's a class, loosely. No, well, not loosely. It is a class in the JavaScript sense. So this is the parent flow object of the node, and it has handle status. Now this is where a lot of the handling of catch nodes and status node, well, not catch nodes in this instance, for handle status, this is where some of the logic for status nodes exist. We're not worried about that. This is the magic that we are concerned with. So by calling handle status, it emits in the internal event emitter a node status event with the ID of the node emitting it and whatever the provided status was. Okay. To jump to the answer, here we have the comms module. So comms, it sits in, again, still in the runtime, and this is what deals with the runtime side of the the logical WebSocket connection between the runtime and the browser. So this module is listening on the node status event. So when a node status event, it triggers this handle status event function. Handle status event. So it wraps that event up. It creates a proper status object with text, fill, and shape, pulling out from the status that's been passed in. And then it calls publish. So the comms connection between the editor and runtime is a sort of publish-subscribe model. The editor sends down subscribes to topics it's interested in, and the runtime can publish. It's sort of modeled after MQTT. It's not MQTT. It's much cruder than that, but it sort of shamelessly steals some of the semantics of MQTT. So we call publish, and we publish on the status/event ID, which will be the node ID. So status/ID, the payload is the status object, and true is the third argument. So if we look at here is the publish function. So the topic, the data, and retain. So if you're familiar with MQTT, retain is a flag that says store this message against this topic, and if someone subscribes to this topic in the future, give them this message. And you can only retain the most recent message, or you can only retain one thing on a given topic. So in here you can see if that third flag, the retain flag, is true, we just add it. We add it to this retained topic, retained object keyed to the topic and its value. So when someone later comes and subscribes, say to status/hash, using the MQTT sort of like semantics, the runtime will go and then look at all of the retained messages that start with status, and we'll just send them all up. And so we're homing in on this behavior where each time they deploy, they're seeing this storm of extra messages coming through each time. So to kind of see it for ourselves, what I'm going to do is I'm going to set up a little bit of debug code, set immediate, because I'm going to console.log the size of this retained object. How many messages have we got in our retained topic? And remember, there's going to be one per node, so this shouldn't. Let's do it every 3 seconds. So every 3 seconds, this is going to print out how many retained messages we have. So that's automatically restarted. Although I'm not seeing. What have I done? Console.log. Why am I not seeing any log messages? Set immediate, every 3 seconds, console.log, object keys, retain.length. And we're in here, that's all goodness. What's going on? Okay. What is going on? Why? What have I done wrong in the first bit of code? Because again, I'll let you know a secret. I've already been down this debug route earlier today, and this worked just fine this morning. What have I done? What's every 3? Oh, no. Not set immediate. Set interval. There we go. Cool. So now you can see every 3 seconds or so, it's printing out how many retained messages we've got. Not worrying what they actually are at this moment, but you can see we've got 8. So for the flows I've got here, if you think of it like our steady state in terms of how many retained messages we have, the answer is 8. So if I just hit deploy, so I've not added any nodes, not removed any nodes, it's jumped to 17, which is curious. And if I hit deploy again, now it's gone up to from 17 to 18. And if I hit deploy again, it's going to be 19. So some very strange things going on here. This first time I've hit deploy, it's jumped from 8 to 17. And then each subsequent one, it's increased by 1. So, in the interest of time, let me reveal what's going on. There's a bunch of stuff going on, and we're going to work through each of it. The one I'm going to start with is this growth of 1 every time I deploy. So 17, 18, 19. What's going on is this subflow. This subflow, if we edit it, contains a debug node. If I pull up the debug node code, the debug node, somewhere in amongst all of this, sets a default status whenever that node is a new instance of that node is created, or the node is created, and it calls this.status with an empty status, so that ensures the status is clear. Now we're going to come back to that because that's something we can improve, but more immediately, that debug node is inside a subflow. Whenever we redeploy or restart a subflow, the way it works is it takes the subflow template and it actually instantiates a concrete instance of it. And all of the nodes are randomly regenerated. Which means, whilst this subflow has got a debug node with an ID of, you can see over on the right there, 8DCA, whatever, in the runtime, for that one particular instance of the subflow, the debug's got an entirely different ID every time that subflow is restarted. So that means that debug node, when it logs its status, the retain table is getting a status message for the node inside the subflow against its ID. And every time you deploy, the existing instance with that ID gets stopped and a new one created, and it will log its message. But that old retain message is still just sat in the retain table, and because that ID no longer exists, there's nothing to tidy it up. And that is the root cause of the original issue, which is because they had 30 or 40 subflows and some of them are nested. So they had a lot of nodes that were being completely regenerated in terms of their IDs every time. So what do we do about this? Well, what we do is we need a way to explicitly clear retained status messages. So if we go into comms, where we've got this handle status event, at the moment it does kind of assume that event.status exists, which, to be fair, it will, because the only place we admit the status event is here, where we know that status is going to be set to something. So first up, what we're going to do is we're actually going to say, well, if event.status doesn't exist, we're going to take that as a sign that we should delete, that there's no status report, and that we should delete the retained message. So what we can do at this point is do delete of retained, and we know the topic ID is that. Otherwise, if there is status, then we do the usual task of going ahead and publishing it. Okay. So now if we were to trigger the status event with a non-existent status object, it will delete the retained message and not do anything else because there's nothing else to do. It won't go on to publish it. So now we've got a mechanism to delete the retained status message. We need to actually do something with that. Now, what's the point in the life cycle that we want to do this deleting? Well, it's going to be when we're stopping the subflow. We're stopping the subflow instance, so we need to tidy up all of its nodes. Now, let me go find. So back in flow.js, so this is the class that represents a flow. The subflow is a subclass of flow. So it actually shares a lot of the functionality of a flow, and it just has some specializations for some of the extra work subflows have to do. And as it stands, it does not have any custom code around stopping, but it's about to get some. So what we're going to do is we define a stop function, and I can see above, I'm just going to crib this line. So we still need to call the parent flow, the superclass's stop function, because that's still work that has to happen. But what we want to also do is emit all the events to tidy up the node statuses. So what we're going to do is build up a list or get a list of the active nodes. So this .active nodes is a object of all the nodes inside this subflow. And because when we call super.stop, then active nodes will get wiped out, we capture a list of all those IDs of the nodes in this subflow. We're then going to stop the subflow because that might drive status events depending on the nodes. And once we've done that, let me just quickly flip back, stop. Yeah, okay, so this needs to return a promise. I must remember, yeah. We're going to return super.stop that, and once that's done, let me just double check. Yeah, we're good. So once that's done, so we've finished stopping all the nodes. That means any status updates they're going to do, they're done. We can then do a nodes for each, which for each of those IDs, we are then going to just refer back to flow.handleStatus, what it does. Oh, if I jump to the wrong place. Handle complete, handle error, handle status, right. It's this emit event we want. So for each one of those, we are going to emit the node status event, but with no status. Okay, does this make sense? So we're capturing the list of nodes that we're about to stop, we stop them, and then for each of those, we emit the node status event with no status object. And that will clear out the retain table. So if I switch back, there, it's automatically restarted. So there we've got our 8, which is what we started with before. Let's hit deploy. And we've gone up to 16. That's okay. We'll come back and look at that one next. Now if I hit deploy, it's got confused. Hold on, let's just... Hold on, what's going on? Okay, things have got a bit confused. I'm going to restart Node-RED. So there, the runtime state had got slightly confused about deploys. Maybe I've confused things. Let me... Okay, so here we've got 8. Yep, we're looking good at 8. Hit deploy. Oh look. Look. I have mucked it up. It's stuck here at stopping flows. It's not resuming. Okay. Is that because I need to... I suspect that might be because I'm not returning the result of... Okay, I'm not going to dwell if that's fixed it, which I think it may have done. Let's just check. Right, so we've got 8 retained messages on a clean restart. I hit deploy. No, see, it's stuck on stopping flows again. Okay, that means I have mucked something up. Is it because... What have I done? Is this throwing an error and I'm not catching? This is the trouble. There are certain code paths that we don't log errors because it's sort of quote-unquote impossible for errors to occur, except for when you then start developing the code and things creep in. So let's see what's going on. I hit deploy. Ah yes, we are getting stack traces. Events is not defined. There we go. So yes, I'm trying to use the events module, but we haven't imported it. So let's just go grab the require statement for the events module. So I hit deploy. That's good. So now you can see it's gone through the full cycle. Yeah, this is good. So we've jumped up to 16 and we'll come back why on that in a moment. Hit deploy and still 16. 16 is unfortunate. The fact I'm doing this on the 16th of November and we've got 16 events does make for a lot of 16s in the log. But key point is it hasn't gone up. So the work we've just done to clear out the now defunct subflow instance status messages is good. Hurrah! You know, pat ourselves on the back. That's an issue fixed. However, this jump from 8 to 16, if you look at the flows, other than this debug message, which has a little grey rectangle you can probably just make out, none of my nodes are actively reporting any status. Yet, every time I refresh the editor, there are 16 status messages having been sent to the UI. And you know, this is 22 nodes. Someone with 1,000 nodes, well, that's a heck of a lot of work, particularly when, you know, why should we be telling the editor about a blank status that doesn't need to be displayed? So that's the next piece to go look at. So we've got 16 bits of status. Let's go and understand what are those 16 bits of status. To do that, I'm going to go into flow.handleStatus. And here where we emit the status event, I'm just going to throw in, for the sake of debug, I'm going to also report the type of the node. So we can look to see, are there any other patterns about what status events are being recorded by whom. So we've got event.type, event.id, and the status itself. Okay. So now, right, so just by starting up the flows, you can see we have a bunch of status messages, 1, 2, 3, 4, 5, 6, coming from debug, but look at their properties, undefined, undefined, undefined. The debug node is spamming things quite badly. Now there are 6 there, and you may say, well, Nick, what about the other 2? There are some genuine system retained messages that are just part of how things work, nothing to do with nodes, to do with flow management. So two of those retained messages are legitimate and are allowed to be there. But here we have 6 node statuses come from debug nodes, which arguably only one of them is actually useful because it's going to display information to the user. Let's have a look at that. What's the list look like when I hit deploy? So having hit deploy, you can see, so here's where we've started stopping the flows, and we've had the subflow report status, we've had 2 function nodes report status, and again, look, all undefined, and we've had 5 HTTP nodes all report blank status, as all part of the stopping flows work. Now the reason they do that is the function HTTP request nodes. So you can actually see, here I have my 5 HTTP request nodes. There are 5 there because from the work I did earlier today to understand what's going on, and there are there's the 2 function nodes. Those are nodes that legitimately can report status. So both of those nodes, and as well as many others, have code in their close handler, the function that gets called when the flows are being stopped, to clear their status, any existing status they may be showing. So if the HTTP request node is in the middle of doing an HTTP request, or maybe it's finished with an error and it reports errors partly as in status, it's setting it to a clear to an empty status message in order to clear visually what's displayed, because you wouldn't want to reload the flows and the HTTP request node reports an error, when in fact the error was a while ago. You've done a deploy since then, and the current state is actually clean. And that's why the debug node... Well, okay, so there's kind of 2 approaches here. So the debug node sets an empty status when it starts. The function and HTTP request node sets an empty status node when they're stopping. Both pose challenges, and both are there trying to set a clean... The debug node is setting a clean slate when it's starting. The other nodes set a clean state when they're shutting down. So, what can we do to improve things? The reason we set this retain flag is so that when a new editor connects, it can get the current status of the nodes. It's much less about an editor that's already connected, like this one here. It's already connected, so it's subscribed to the live status events as they happen. Now, the thing that I realised earlier today is there is absolutely no value retaining a blank status message, because for a browser that's, for an editor that's still connected, already connected, we can publish the blank status to clear it on screen. That's fine. If a new editor instance connects, well, it doesn't have any status to clear. There's no point telling it to clear status that it doesn't already have. So, all of these status messages that we are retaining somewhat needlessly are blank. Now, whilst we could go and fix logic of individual nodes to only clear their status if they know they've changed something, that's not a great solution, because there will be plenty of nodes in the community who have sort of followed our lead on how to use status and do this sort of thing. And experience tells us that coming up with design changes that nodes that we want the community to apply across the board, it doesn't happen, or it takes so long to happen. It's not a great result. So what we can do is actually something far more useful in here. So I'm back in the comms module where we handle the status and where we do the publish with the true. What we can do here is we can say, well, actually, if event.status, if it's blank, so it doesn't have text, and it doesn't have fill, and it doesn't have shape, okay? So it hasn't got any of that. What we can do, we still want to publish it because we need to pass that information to connected instances, but we can publish it without setting the retain flag. So we won't remember this. We will publish it to the connected editors, but we won't remember it. And if we look down at the publish function, that already takes care of if you publish something without the retain flag set, it will delete it. So that's going to tidy up for us. So any node that publishes a blank status is now going to automatically tidy up from the retain table its status. Okay, so instantly, because Node-RED has restarted when I hit save, you'll notice we've only now got 3 messages, because the only one we've actually stored, aside from the 2 system ones, which we're fine with, is that one debug node that's genuinely using status and it's genuinely initializing its shape to a grey ring. Okay? And then if I go and just change something and hit deploy, notice how we still only have 3 retained. Excellent. We're now no longer storing the empty status objects as retained messages. Isn't that good? Isn't that awesome? Isn't that everything? Close. We're getting there. But there's more there's more to do. And at this point, I've now caught up with what I did earlier today, playing around with this stuff. So for the next 20 minutes, this is now new territory. I've switched over to the editor client source code and the comms file in the client. So this is the browser side of the comms, the WebSocket connection between the editor, between the runtime and the editor and the runtime. And somewhere in here, it will have right, yeah. So whenever it receives a message, it parses it, it does some work, and then it goes and looks through its internal table of subscribers for who's subscribed to the topic that's been published on. And in fact, I don't want to be there, I want to be in red.coms.subscribe. So there are notification events, we're not worried about those. Status events, here we are. So we're going to call console.log so this is where we do the subscription to any status/hash. So for those not familiar with MQTT, hash is like a wildcard. And because we publish node status on status/the ID of the node, that will match. And here we split out the topic so we can get the ID of the node this status message is for from the right hand side of the slash. But we're just going to do a console.log. Let's open up the console. And now if we reload, so we've only had the one status message come through. Well, that's good, because it's the genuine debug one. If I hit deploy, look at this storm of blank statuses we've sent through. So again, that's the function node, the HTTP request nodes, all of them sending through that blank status in order to clear out the UI. Now we've done the fix on the runtime, so we're not storing those in the runtime, but we've still sent that over the network to the browser. Now imagine if I had a couple hundred HTTP request nodes. That's a lot of busy work for doing nothing. So let's look back at our logic for when we choose to send. So back in the runtime. So we've said, we just added this line, or this pair of lines, that if the status object exists but it doesn't have anything, it's a blank status object, then we're still going to publish it, but we don't retain it. Now there's a we need to do that if we have something to clear. If we have nothing to clear, then we don't even need to bother publishing that message to the editors. And how do we know if there's something to clear or not? Well, we know that because the retained table will have an entry. So what we can do is we add an extra if statement in here that so we've received a blank status. We have a retained status for that node, i.e. a non-blank status, in which case we publish the blanking one and we set false to clear it. But if there is no retained message for that node, we don't need to bother sending anything. Okay, so now when I reload the editor, we should see the debug node status, because it's a genuine status. I hit deploy, and the only status message we received is that debug message being updated. Isn't that good? Let's add in, just to check this isn't a fluke. What is this code? Oh, I have no idea. Delete that. We're just going to do a node.status hello. Deploy that, and again, look, we've only received that one status message. Let's make that big so you can see it a bit better. I trigger this debug, and look, we've got the function node status saying hello, and sure enough, here you can see the status of hello. If I make some change and hit deploy, this time we have received that blanking status message because it's because we had the hello text and we wanted to blank it, so now it's been blanked. So here we have 3 retained messages, and if I again just show this in action, there we've triggered the status, and you see we have 4 retained status messages. I mean, that's all good, that's all working. I hit deploy, it's cleared it out, and we should be back down to 3. So that's now working. We have saved, so we're now properly tidying up the subflow orphaned node statuses, and we are not retaining the blank statuses, and we're avoiding sending blank statuses to the editor when there's nothing else to do. I think that's pretty good work. I mean, that's, even on this small scale, we've gone from a storm of like a dozen status messages down to 1. So for the original issue report where they had thousands of nodes, 40 odd subflows, I mean, this is going to make a huge difference to the performance to their stuff. So yeah, that's all goodness. One other possible area, I'm just going to tidy up, remove some of these. I'm going to remove the set and interval because it's served its purpose. So one other piece to consider when we go look at the comms, where is it? So the comms link in the runtime, there's actually two halves to it. There's sort of the core runtime logic of comms, and then separated out is the actual WebSocket handling. Something we want to try, we could consider doing, and I'm not going to get into now with like 15 minutes, less than 15 minutes to go, is the WebSocket would be much more efficient if we were to do a bit of batching up of those subflow messages where we have these large storms of lots of status updates to send. It would actually be more efficient to batch them up into there's still individual events over the WebSocket, but events over the WebSocket, but we send them over in one block. The editor, have I jumped to the right place? Yeah, so on the editor side, on this on message, it receives the data and it parses it, and then it already expects the message to be an array of individual messages. And that's because in here, so this is back in the runtime side, we already do batching. So we do a 50 millisecond window. So if you were to get lots of status messages arrive within 50 milliseconds, they would get batched up and sent in a single block. So actually, I forgot this code was here. So I'm not going to go near it because that is already doing what I thought we'd want to go look at. Yeah, so this is good. This is good. Now, a couple of things to go think about. Because we want to try and be good citizens and do the right thing. The debug node has got some duff logic in it. So because the debug node can log to status, when it constructs the debug node, if toStatus is set, then it sets a default status of a grey ring. Otherwise, it sets its status to an empty object. Now, all the work we've just done means that empty object isn't going to go anywhere. It's not going to, because this is a brand new node. It's only going to do anything if the previous instance of this node with this ID had set some status. So maybe the user has changed the configuration of the node. Now, in the interest of avoiding unnecessary work, what we're going to do is get rid of setting a blank status because it's pointless. Somewhere else in here is the I spent ages in here earlier today, but I never sort of tracked where physically in the file because I was jumping around so much. Here we go. So set node state. There's a bit of duff broken code in this node. As you will know, you can mute and unmute debug nodes using this button. That only applies if it's muted to the debug sidebar. It doesn't mute the status. Now, it's been quite intentionally written that way But I think there is some legacy code here that suggests it wasn't always intended, or an early iteration intended for the muting or deactivating the node to also deactivate the status as well, because this is the function that gets called when you toggle the status, either setting it to active, true or false. And it's got this stuff around, it sort of clears the status, or it restores an old status when you unmute one that had old status. I won't go through. There's I know this is duff code because it's looking for a property node.oldStatus, and there is no code in this file that sets old status. Now, there is code in this file that sets old state. So I think there's a bit of a typo here, because here we have code to do with the legitimate logging of status from the debug node, that to avoid overloading the traffic, it works out what status it wants to set on the node. It then compares it with whatever status it sent previously, old state, and only if they differ does it update, does it send the new status report. Yeah, so what we're going to do is we're going to just tidy this up. Because toggling the active state of the node has nothing to do with status, I'm just going to delete those lines of code. They were doing nothing before. Okay, then here where we're setting old state, what I'm going to do, so yeah, it compares the new status, what it wants to set, with what it last sent. What we're going to do when we initialize the node, because we know we only update status when this is true, I'm going to initialize old state to be the empty object, just so it's something. Is that right? Just whizzing through in my head if this logic is sensible. No, I'm going to set that to the empty string. Am I? No, I'm not going to do that either. I'm going to... No, in fact, I'm going to set it to the empty object. And then what we're going to do is we're going to add in... Where is it? We're going to say this.onClose. And we're going to say if this dot old state, yeah, if it exists, if it's any string value at all, that means this node has set a status to something. And only at this point we will clear it. Okay, so what we've got here is now, rather than setting a default status whenever the node starts, we will now clear the status when the node is being stopped, but only if the node has actually set something. So again, it's just a little bit of housekeeping, tidying up code. The other one I wanted to quickly look at was the function node. If I scroll down through it, here we have node.close. So here you can see it does a node.status when the node's closing, irregardless of whether anything has happened with status with this node. So what we're going to do is we're going to add in a instance variable on the node called clear status, and we'll default it to false because by default there will be nothing to clear. And then here in this status function, which is what gets called if your function node calls node.status, we're going to say node.clearStatus equals true. So it's done something. Now, we could examine what the arguments are, because if it's a blank status, then we don't need to bother, but I think at this point, if they've called, the function node has called status at all, let's assume there's something to clear. And then we come back down to the close handler. And then rather than just blindly calling node.status, we only do that if there is something to clear. Now, I could carry on searching through all the other core nodes, but in fact, because it was there, the HTTP request node. Just make sure I'm looking. Oops. So if I just search for where it calls status whenever it receives a message, because it's when it's starting the request. Sets it to red if it gets an error. Sets it to red, again, more error cases. Otherwise, if the request completes, it sets it to the blank and calls done. Now, yeah, there's actually some interesting. What I was going to do, well, I should finish the sentence. And here you can see the close handler, which calls status, so it clears out any status if there is one. Now, I was going to do a similar task. There's actually an interesting race condition here that this node could be processing more than one request at the same time, and status is sort of single-threaded, if you like. You can only show one status, even if there are multiple requests being handled at the same time. So, but for the sake of this is going to be worth doing. So we're going to do the same deal. Okay, so set clear status to false. I think as soon as we receive a message, we'll set clear status to true, and then no, I tell you what, I'm going to cancel that. I think there are too many different branches where I don't want to screw up. So whilst it's fairly clear cut on the function node and the debug node, I'm going to leave the HTTP node alone, knowing that all the enhancements we made to the core will remove a lot of that redundancy as well. Okay, so let's just make sure. Let's make sure I just remove the debug I threw in. Let's go have a look at. Let's go review the changes. So that's just an unused variable I removed this morning, which is good. So debug node, we now, I tell you what, I've not actually verified that. Let's just test the debug node and then we'll get this committed and then we are done for another week. So let's wait for that to spin up. Plus also a quick check of, okay, so I'm injecting, setting the status on the node, that's goodness. I hit deploy and you can see it's cleared the debug. It's cleared the status of the debug node until the next one arrives. So that's still working. That's the only test I wanted to do for that, show that that's still working. Okay, so debug node done. Function node, we set this flag. We added a clear status flag. Oops. And then we only clear the status if that's been set to true because the user's code has set a status. Good. In the comms module, so when we handle a status event, we've added the ability to delete retain messages without passing anything on. Always handy. If it's a blank status, we only publish it if there's a non-blank status that's already stored, and we publish it without the retain flag set to true. So that will clear it, but then move on. Yeah, that's all good. Okay, so that's that file. In the flow, we added node.type. That was purely for debug. I'm going to revert that. We don't need that for what we're doing. I'm pretty sure, let me just double check. Pretty sure I took out the console.log. Yeah, no console.logs. And then in the subflow subclass, we added the events module. We added the stop function for the subflow, which grabs a list of all the nodes in the subflow. It calls the superclass's stop function to actually do the stopping, which is what would have got called before we added this function. Once that's finished, we iterate over all those nodes and we emit a node status with just the ID, which will delete that retained status event, and then we return. Now there is actually there is another path that we've not looked at, but I'm gonna either look at tomorrow or another day. If you delete nodes, if you delete nodes and hit deploy, I don't think we will be tidying up their retained messages. So that's something I want to go look at. It's that's something that needs tidying up. So I'm going to look at that, but I'm going to look at that tomorrow morning. For now, this is good. This is going to fix a considerable memory leak. And it's interesting. We've known that there was a memory leak around deploy, but we've never been able to nail it down. It's something to do with subflows. So I'm going to be intrigued to see whether this is the actual memory leak that we've seen, or the thing that doesn't cause this random background increase in memory usage that we've just never been able to fully get to the bottom of. Certainly subflows with lots of debug nodes, lots of function nodes would be leaking these retained messages. So yeah, really pleased with this fix tonight. And that's the thing, sometimes it does just take this issue was there to be seen. Sometimes it just does take someone to spend a bit of time investigating symptoms that they see, even without knowing all the ins and outs of the code, just to spot a pattern of behavior. And often that pattern of behavior can be invaluable in getting to the bottom of what's going on. So let's just close this out. We're going to commit all that. Prevent. I've thrown in lots of things in the same commit here, which is a bit naughty of me. But prevent needless retention of node status messages. Done. Git push. Git pull rebase. Who's merged something to master? Dave, what you been doing? I say that jokingly, but I mean it. Russian locale. Cool. Yes. So we'll do the Node-RED 1.2.4 release tomorrow, hopefully, and it adds Russian support to the message catalog. That's been sat there for quite some time to get merged in, so really good to see that finally land. So yeah, there we go. As I said, really pleased with tonight's effort. That's one of those changes that feels more meaningful in terms of solving a real issue, a real memory issue that will make a good difference to users who are using Node-RED at scale. And that's something we really want to put some real focus on, because sat here with my laptop, it's hard to test and debug things at the sort of scale that some users are using Node-RED. So, it's always great when we come across these things that we know we can make for what was really 10 minutes work. I've just spun it out into an hour because I've been talking through it with you to make a real meaningful difference. Excellent. So I'm going to leave it there. If you're, like I said, thanks for joining the chats. Thanks for saying hello. If you are watching the YouTube, do like, subscribe. I'll be back every Monday doing whatever needs doing. With our current release plan, the 1.3 milestone release in late January, we really need to start cracking on new features for that. So I'm kind of hopeful we can start digging into some new territory on this stream over the next couple of weeks or next few weeks. But otherwise, I'm going to sign off. Thank you for joining. Thank you for watching. Like I say, do like and subscribe. Follow me on Twitch. I'll be back next week. Stay safe. All the usual public health messaging. Oh man, I need a cup of tea. Good night, everyone. Thanks.